like to thank the Academy of Sciences, especially Professor Raghavan, for giving me the opportunity to deliver this lecture. This is a special lecture, and it's special for me also, because normally I'm not used to giving public talks which could be of general interest. I'm more used to giving research talks in my own domain, but when Professor Raghavan asked me, can you give a talk which is of general interest, if I pick something out of my research basket, I can relate to only some of you. So I was wondering what I would pick as a possible topic. So I chose this, digital transformation and environmental sustainability, because I feel that as a scientific community, we need to have a wider perspective of what's going on in this world, which has implications in various fields, including geopolitics. So we are all aware of what digitalization is about. We use mobile phones, we use laptops, tablets, and using these devices we connect to the internet, we do video conferencing, we do Google search and then AI tools, and we are also, as a scientific community, conscious about what kind of environmental footprint that this field can have. And more so because this change that is happening is very rapid. And with this rapid change, it is giving rise to demand, or huge demand, in mainly two kinds of commodities. One is critical minerals, and the other is energy. Critical minerals because the hardware needed for the digitalization, especially the high power AI chips nowadays, they need critical minerals to do certain special functions. And that includes also mobile phones, it includes electrification of transportation sector, batteries and so on will need special materials which are called the critical minerals. And to power these systems, we need enormous amount of energy for data centers and the network infrastructure that is created around everything. So with that background, let me move ahead with the topic, and what I would do is maybe we can dim the lights a little bit so that the picture, is that all right with everyone? Yeah, thank you. So let's read the title from in the reverse order, sustainability. So what do we mean by sustainability? We have some idea about it. And sustainability has many kinds of definitions and many kinds of understanding. The official definition of sustainable development is given by the United Nations. It just is a very simple definition that development should meet the needs of the present without compromising the ability of future generations to meet their own needs. So very simple definitions which we all understand. But human beings need to progress, and we have our needs and the ambitions which are growing very rapidly again. For that we would need resources which are energy, water, land and food. And when we talk about this sustainability, environmental sustainability, we are talking about air, water, soil pollution, ozone layer depletion, global warming as the three pillars which we need to address. Now to begin with, let's see from an energy point of view, what is the primary energy consumption by source. This is a 2024 data, and what it shows is that if you see 2024 data, oil, gas and coal, the fossil fuel still is much larger than wind, solar or other renewables, even though we have made tremendous progress in this. And there is you will hear that so many gigawatts and terawatts of renewable energy being generated, but don't go by the nameplate capacity only, because something like solar, it may say 1 gigawatt, but it may be giving that peak performance only 2 hours a day or 4 hours a day, and sometimes in some days nothing at all. So this is the actual picture that is there. So now let's look at it by country. The biggest consumption is China and then United States. China, because that's a factory of the world and they make almost everything that we are using in the rest of the world. So just let's keep this in the background right now. We'll visit this later scenario. And since we are talking about fossil fuel still being the largest source of energy, so this is the scenario with the oil reserves, if you see. And something which is this maroon color, like dark red, it is in terms of billions tons. Something of a lighter shade would be much less than that. And where do these exist? If you see that the largest reserves are Venezuela and Middle East. So you can connect the dots later. I will come back to it. Okay. Now, what are the sustainability issues? One issue is about the depletion of the fossil fuels and the other is the climate crisis. At one time the depletion was like in the 70s, more concern was about the depletion of the resources. But now the climate crisis has taken over, especially with this rising CO2 increase, and that is leading to global warming and other effects that we are all aware of. And to address these, there are policy agreements and frameworks. So the key international agreement, there are many agreements. This Paris Agreement is what we refer to always, and that's the that's the guiding agreement that we are still abiding by. And there are supporting frameworks which have been created, including the IPCC, UNFCCC. And under this, there is a COP, Conference of the parties which have engaged, all the parties means all the countries which have engaged and signed or pledged that we need to mitigate the climate change or address the issues. So these meetings are held every year. So, based on the COP meetings, which is working under the Paris Agreement, there are limits that are set. That is 1.5 degree limit of global warming, so to contain the damage that is happening. And then there are 2030 targets which came up at COP 28 and beyond. So the focus in 2030 target, the focus was on the renewable energy and efficiency. And then there was 2035 target, which is again re-emphasizing the 1.5 degree limit, and 2050 target, which is net zero, that we will not use fossil fuels at all, everything will be renewable or clean energy. So let's keep that in the background. So based on that, there are some decarbonization routes. Decarbonization means we will not produce CO2 or reduce it as much as possible. So the decarbonization routes, one is the generation of energy would be, as we all know, solar, wind, hydro, nuclear, etc. And the electrification of the transport, including home heating and industrial operations. And what it turns out that we need also storage, so therefore we need a mix of electricity and clean fuels. So there is a terminology called the power to X, P2X, which means that you can use renewable power, but you need also something like a fuel. So there's the indirect storage of electricity is via conversion into fuels, beginning with hydrogen, and then you can reform it to other fuels which can be more easily used. So the key thing is basically the energy storage. That's the success that will lead to the success. But the electricity storage in batteries, in small scale, it works out fine. That's why in large scale it is a little bit difficult, because that will also cause environmental issues with so many batteries. So green fuel is also looked at as large scale, and thermal storage is the other one. So these are basically as far as storage is concerned. Now let's come to the main theme of today's talk, which is the digitalization and the growth and what kind of environmental impact it can have. So these are just some tidbits and snapshots of how things are changing. For instance, the carbon footprint of the digital world is creating about 1.5 gigatons of CO2 equivalent. and the raw material extraction for the critical minerals and other materials, just a snapshot, if you see a 2 kg computer, it requires extraction of about 800 kg of raw materials. Then there are data centers. I'll come to this in more details later on again, and if you see that in 2024 data centers have been consuming 415 terawatt hour of power, and in 2030 it is estimated to be 945, and there is also accompanying water usage from 0.2 to 1 liter per kilowatt hour of energy that is used in the data center. And then there are these infrastructure devices, how it is growing. If you see, the 5G coverage is expanding from 2021 is 25% now, is projected to be 85% by 2028. Then IoT devices, this is how it is increasing. So this is just a tidbit snapshots, I would say, just which is painting a complex picture of the digital economy's environmental impact and how quickly things are changing, and very difficult to even keep track of all that. Now, but at the same time, there are positive impacts which we all use. We use computers and computation, simulation, and all the tools which would be used for our research and efficiency of engineering activities and industries. So research efficiency, supply chain, everything becomes more efficient when we use digitalization. And then environmental monitoring, weather prediction, everything is aided by this one. So there is a positive impact of it. And also in circular economy, many things we are able to simulate and predict. So therefore we are able to take better decisions in this one. So all is not bad. So I am pointing the other side as well, which would be beneficial. But what are the challenges and negative impacts? Energy and water consumption, the growing demand for the data centers and the AI systems, as I was just discussing. They are increasing energy consumption in those sectors. Then environmental waste, how to recycle them, and I'll come to that in more detail, how difficult it is to recycle many of these materials, especially in the which is used in the digital infrastructure and devices. And the other thing that we need to worry about is a rebound effect. Many times what happens is something more efficient comes in the market, and then we tend to use more. Something like an LED lights when they came. It turns out, we're looking at even the India data, before the LEDs came, the power consumption by lighting alone was much smaller than the power consumption for lighting now that we see after the LEDs came, because we use multiple lights now. We use more of it because we are not paying, we are paying less for the energy, right, that is consumed, or less energy is consumed because of that. So that's called the rebound effect, which is also happening. So, and the nature of digitalization is also changing very rapidly, because there are high speed processing, online transmissions, and our expectations are also more now. The computations and processing have shifted to the cloud, then digital platformization, because there are business platforms like Amazon, Uber, they use it in a shared form, many of these resources. Then cognitive changes, big data analytics, machine learning, AI, all that it is getting into our daily lives, right? And virtuality. Growing use of augmented reality and virtual reality. So all that is changing very quickly. Like shifting to the cloud, for instance, many things that we use at one time, even 20, 30 years back, most of the processing that was done, it was done on our device. If it's a computer, all the processing was done there. But nowadays, we can use a mobile phone and hardly any processing is done there. So there are apps which are basically interfaces. We send information to, it goes to some cloud or data processing center, and the information comes back and we get it. So nothing is done actually, or virtually nothing is done actually on our devices. So basically we are relying on the cloud. So many times we don't even realize what we are doing to the environment by just googling something or using a ChatGPT even to get a simple answer. Should I mean, what should I buy for my groceries today? Something like that. We use ChatGPT today. Anyway, so then what is the nexus between the digitalization and environmental sustainability? We call it also twin transition, because while we are transforming to a digital economy, we are also trying to push our economy towards a low carbon economy. Till one point, they were parallel because they were serving the same objectives. Because we have used digitalization towards environmental sustainability by reducing paper consumption, energy consumption, and so on. But today, it is becoming interdependent, and not only that, it's competing and conflicting. And that's what I want to bring in front of all of you today. The digital tools, of course, they are increasing the efficiency and resilience. Digitalization itself must be made more environmentally sustainable. So that's the objective that we should have. And the other thing is that both sectors are, from a material point of view, they are using the same rare earths or critical minerals and metals and inputs, if you see, because our photovoltaic system or renewable energy also uses many of these materials. At the same time, from a consumption point of view, in our digital world also, we are competing with the same materials and resources. So there's a resource competition, and this is also leading to significant changes in international trade and the geopolitical challenges that it is bringing up. So how to assess all these? There are tools, and those tools are called the life cycle analysis, because you cannot just look at a product and judge whether it's good for the environment or bad for the environment. We need to look at life cycle, means that right from the minerals that we are extracting all the way to recycling of at the end, after the end of life. So there are basically phases. There is a build phase of a device, there is a use phase, and then there is a end of life phase. So that is we are looking at also the production, supply chain. Now, what has happened is, now most of the digital economy until now has remained linear, which means that it is not belonging to the circular economy as yet, because we are producing, and at the end, so many mobile phones I have used. I don't think I have recycled any of these yet. They die and somewhere they disappear, even laptops and other things, right? So it has remained mostly linear, which is not a good news. So we need action, which is reduce, reuse, and recycle. This LCA, there is a standardization procedure of how to calculate, because there are so many different ways of calculation that sometimes we can project a thing to be very rosy. We can give a rosy picture, and sometimes very dark picture also, depending on where you are coming from and who is funding the research. So that standardization is an important thing, and it encompasses multiple criteria beyond the greenhouse gas emission line. So if you look at the ICT sector infrastructure, basically there are three elements in it, major elements in it. One is the data center where the processing happens, then there is a network infrastructure, and there is an end user devices. End user devices is what we are most familiar with, our phones, laptops, and IoT devices, and they are all interrelated and interconnected in a digital way. So coming to the life cycle analysis, as I was mentioning, we have a production phase where we are extracting and refining the raw materials and then manufacturing that device. Then there is a use phase, and this is where the energy is used in our devices. That gets taken into account, and in the use phase, energy use and water consumption and the greenhouse gas emission, these are the issues that we look at. And then finally the end of life phase, which relates to the circular economy, that how it can be recycled. Okay. Now coming to one thing at a time, we will focus mostly on the production phase and the use phase, because the end of life phase is another domain which I will not touch upon, that is more complex. In the production phase, if you see your smartphone composition, the metals amount for about 45%, and these are the other materials which are there. And there are critical minerals in this because of the functionality that it has to do. And even there is growing demand not only in the ICT but also in the EVs and solar panels, those critical minerals. Right? So now I don't know if you are aware what is in your smartphone, and let's find out what you are carrying in your pocket. And this is the periodic table which we are all familiar with. So all the colored ones, the colored boxes are basically in your pocket. Okay. And gradually some of the others may also become colored. And if you are looking at other devices like EV motors and photovoltaic panels and everything, then some of the other boxes will also become colored. So now the dynamics of all this is that there is an exponential growth in internet and data traffic. There is higher computing power, better mobile technologies, and greater consumption of digital devices and hardware. So that's increasing in the building of ICT data infrastructure, and all this is resulting in increased demand for minerals, metals, and materials, right? So, and the energy part is also there, right? So as far as minerals and metals are concerned, see, it is a finite planet and we are extracting. When we are extracting, what is happening is that if you look at that, also is increasing from 16% in 2022 to 34% in rebound in 2020. I mean, this is global exploration budgets are rising, especially in these countries where the resources are, and now the tech giants are looking at even deep sea mining and space mining. There are trillions of dollars of budgets that are being put now there, and people are investing money. So that's a kind of challenge and uncertainty that we are going to, because so much of demand is being created. So now to look at how the global concentration of minerals and metals exports are, if you see that mostly it is concentrated in Africa, some in Latin America, Australia, and some other countries. China also has a share in this one. And so these are the places where most of the those minerals and materials are. But if you look at processing, because it's just not enough to extract the materials, you need the processing technology, and where it is most dominant, the dominant processing is actually being done in China, which is the blue color. So any of these materials, the share of mineral processing is dominated by China, that you see. So it's not just having the materials, but also the materials technology for processing. And so the impact of the production phase, which we are going through right now, associated with mining, the greenhouse gas emission, water use, pollution of soil, and other effects. And there are social impacts also, because these are creating issues about people's health and safety, communities, particularly indigenous people. You have to rehabilitate them somewhere else, and the working conditions which people are in now. So that's a different domain which I will not go into, but that's a social issue which we see. And the other effect that is happening is a mineral depletion. Now, why we are talking about mineral depletion? It's a finite world. Minerals are still there. Only problem is that minerals, when we talk about something mineral or an ore, it is in a form of concentrated, a concentrated nature. So when the concentration is high, we are calling it as a high exergy, because you can make use of it very easily. But as we are using it, we are unearthing it and then using it, it goes into so many devices, billions of devices, they are getting distributed. So just a thermodynamic analysis shows that you need, so the exergy is actually decreasing, or we can also say entropy is increasing. So it is more and more difficult that even though those minerals are there, it is difficult to bring them back again to use. So that is where the problem lies. We need enormous amount of energy again for any kind of recycling, because the way it's distributed in the photovoltaic panels or in our mobile phones and all, it is almost impossible, or it needs a very, high degree of purification again to bring it back into circular economy. So that's why we call that the recycling is very energy intensive. So now coming to this use phase now, that was the build phase. Now the use phase, we are consuming energy and water, especially in the form of data centers, and that is leading to greenhouse gas emission, because the power that is required for the data center will have to come from somewhere, and the carbon intensity can vary by regional energy grid composition, and the cumulative footprint, we are talking about billions of connected users devices. Okay. So with that background, let's look at now how these devices are consuming power. These devices are consuming power. If you see, in the desktop will be quite large. This is in terms of watts, right? And your mobile phone will be the least. Okay. But talking about the rebound part, you see that your 17-inch cathode ray tube monitor used to consume about this much of power at one time, but now with all these LED monitors and all, the sizes have become much bigger, so we are now actually exceeding what we were consuming earlier. So that's an example of a rebound effect. But of course, we are gaining quite a bit in terms of functionality and other things. Global ICT greenhouse gas emission analysis, if you see in these, that user devices, so this part is the use phase and this color is the embodied or the build phase. Right. And if you see, in the case of data centers, it is showing a small amount, but I studied a little bit deeper into this one, and the main reason is that the first generation, second generation of data centers, they have almost consumed all the available green energy that is available, that is carbon free energy they have. So therefore, the footprint right now as far as carbon emission is concerned is showing small, but they have used up right now. Now the future energy generation has to speed up in terms of renewable energy or clean energy generation to keep up with it, but the actual energy consumption is much higher than what we see over here. Okay. And if you look at the greenhouse gas emission by the device type, the smartphones especially will be very little use phase, and most of it is in the build phase. But for the other devices, it can be the other way around. Okay. Now the last part of it is now looking at, let's deep dive into the data center and look at the sustainability part. There is a huge amount of electricity demand, there is a cooling and water usage and clean energy trends. For instance, the water usage, the direct water use for evaporative cooling can reach about nearly 1 liter per kilowatt hour of energy that is used in a data center. Now, what we mean by a data center, I will just quickly go over this. See, this is one of the configurations of a data center. There are many other configurations. These are basically cabinets where the servers are kept, and they are the ones which generate heat, and is the chips inside the servers that are generating the heat. So we have a cooling system. This is called computer room air conditioning cooling. So cold, this is an air cooled example, and that the cold air will come and then cool these racks, and the hot air will go back to this air conditioning system, and this air conditioning system again is cooled by a refrigerant or a chilled water system. So this is a refrigeration unit, and this is finally the heat has to be released into the environment through a cooling tower, and if it's a cooling tower, that is where the water is consumed because it's evaporative cooling. Now if you're wondering how am I connected with with this kind of a topic? This is where our research funding comes from. This is also one place, and also in the renewable energy that is used to power these systems. Okay. So with that background, let us look at the quantification of the sustainability indices as far as data centers are concerned. One is called the power usage efficiency or effectiveness, power usage effectiveness, which is what is the total facility power that is required versus the IT equipment power. IT equipment power is when we say a data center is 1 gigawatt, that means it is consuming this much. But for cooling also you need additional power. So that's where the total power comes in, and this is obviously greater than 1. How much greater than 1 is what we are looking at. And then water usage effectiveness is that how much of water we are using divided by the IT equipment power. And so these are basically the indices which are used, and the other index which is used, how much of footprint that it is occupying. So the rack density, especially with AI growth, they are also concerned about how much of footprint and real estate it is occupying. So in the cooling technologies and water strategies, there are air-cooled systems where zero water will be required, but in the air-cooled system evaporative cooling is not used, so you need a huge footprint of cooling if it's a dry cooler. So that amounts to real estate and also other capital expenditure. So liquid cooling is more preferred, and water cooling, especially for the cooling tower, is preferred. So water consumption is something which is unavoidable at the moment, right? And there are also circular strategies where we can recycle the water or capture the water from the cooling tower, so that will reduce the environmental footprint. So now the growth of the data center energy consumption, if you see that in 2024 it's about 415 terawatt. By 2030 estimated it is 945, and it is exponentially growing, because we are only seeing the tip of the iceberg as far as AI is concerned. We have barely started using it. That's what the predictors are saying. So, but where are the data centers are mostly located? They are mostly located in US and China. And what is the kind of response that we are having now as far as the environmental footprint is concerned? I will come to, I'll just skip this part. The critical question is, okay, what is the kind of response that it is happening? And so I'll just give you two case studies, what kind of policies they are bringing in. But before that, let's look at also that the data center build cycle is only about 2 to 3 years, whereas your renewable energy generation and transmission cycle, the infrastructure build up is much larger. So therefore, there is a mismatch of time scale as far as demand and supply is concerned of clean energy. So the two case studies, one is Ireland, where already about 22% of their electricity is going into powering data centers, and it is projected to become more than 30% very soon. So they are concerned, so they have some kind of a policy which they have introduced now in terms of capping, or they have to go through some scrutiny before they can build up new. The biggest response is in US. I don't know how many of you are aware that actually there is almost like a protest going on in many of these states, if you see. So anti-data center referendum passed in Wisconsin. So these are very, this year's news, all these are. Then the alarming environmental impact in terms of heat islands happening, around the data center, because these are gigawatts of heat that are coming into the cities that is being released in a small space. So as far as protests are concerned and policies that are being formulated, and if you see, these are basically they are passing bills which are banning or pausing the data center build up. So this is not the usual red and blue political divide of the US, but all the red ones are actually where the new policies are coming into the picture, which would restrict the entry of data center into some of these states and cities. So, the Indian scenario, we are lagging behind in that one, but we are very excited in building up, because there is so much of investment that is coming in. So, we are gladly accepting them, and the projection is quite high, but we have not yet understood what is the environmental footprint as far as India is concerned. So, I will end my talk by bringing in this question, posing this question: is it sustainable or not? Right. So, if you look at now, there are these tech giants who are going to space or propose to go to space to build data centers, right, with million satellites, and they are also looking at mining in space. Now, these are very ambitious projects, these are very ambitious thoughts. Now, why are they doing it? They are doing it so the moment you go to space for both mining critical minerals as well as the powering the data centers in space, which means that there is that compulsion is showing that they understand and they accept that it is not environmentally sustainable on this earth. That is why they are going outside. And of course, later on, just last 2 months back, SpaceX now admits that it is not they said it is not economically feasible to go to space for these data centers, but they are not yet bothered about or not addressing the issue of environment about it. Anyway, so also I will end the talk by saying that, going back to the slide which I showed earlier, that this is the present energy as far as renewable energy is concerned. So, if the demand for clean energy is doubled in the next 5 years or 10 years, there is no way that we can meet from here. This can't be scaled up. So, we have to rely on the fossil fuel as far as this energy demand is concerned, and that is the reason, or you can connect the dots and see why we are fighting wars on oil still right now, right? And especially by countries which are trying to maintain or establish supremacy in the AI field. Thank you very much, and I hope I am able to.
I've read in different places that these data centers, in order to reduce the cost or other kinds of energy requirements for cooling, they're going to places like Antarctica, sinking a ship and building a data. Is that true? That will have a huge environmental impact
Absolutely.
as well.
So there is a desperation now to go under the sea, go to Antarctica. In India, it may be going to the Ladakh. First of all, it's not so easy, because you also have to carry the data there. That infrastructure is also impossible, but I agree with you. It is, yeah. Yes.
What is the future of green hydrogen?
Future I would say is bright. It's only a question of reducing the cost of production so that it is competitive. Right now, that is a barrier. And the other is transporting the hydrogen, and especially in mobile devices. And also, conversion to other fuel is also being thought about, like instead of hydrogen, it could be ammonia, it could be any other devices, or any other fuel which can be stored easily under normal pressure. Right. So, the storing of the hydrogen is also an issue in mobile devices like the cars and vehicles.
Excuse me.
But otherwise, I think future is bright that way.
Good morning. Actually, I have a question. We are hearing that China is actually building data centers inside the sea, right? So, and of course, that is also not environmentally feasible, yes, because it will affect the marine life. But according to you, what do you think is better, using the fresh water to cool down those data centers, or building it in the sea?
Okay, the building it in the sea is mainly because it's a colder, or year round you get a same kind of temperature as far as the cooling environment is concerned. It is not that they are using seawater that way. So, fresh water is obviously it is not feasible. But if you dump this heat, as I think the same question was asked, if you dump the heat into the sea, it's going to cause other environmental issues. Right? Even 1 degree change in a local area, it can kill many marine, habitat.
Very curious question. If you have to transport heat from the data center in space, how do you do that? There is nothing over there.
It's a radiation sky cooling, basically what we use from Earth also. It will be more efficient over there, radiation, but even that needs a huge amount of area. We have even back of the envelope calculation is showing that for a 1 gigawatt data center you need between 2 to 4 kilometers of total area. 2 to 4 square kilometer of total area in terms of capturing the heat from using the photovoltaic panels and also radiating the heat out. So, and that's why now they are saying that it is not economically feasible. Yeah, you're absolutely right, Professor Joshi. Yeah.
Thank you very much. I think there are many more questions from the audience, but in the interest of time, we should close this session. Please join me in thanking Professor Pradip Dutta.
Thank you.